First up, we have Blaine Brew, who's our Global VP of Sales. He brings with him an extensive background in document management from HP and Experian. He's worked with both federal and state and local agencies to help bring their workflows into the digital age. When he is not talking about how to improve document management processes, he can be found cheering on his kids' teams on the side of the field. Next up, we have Cal Reynolds, who's a pre-sales engineer here in our Boston office. He's worked with numerous government agencies to help identify how iText and their workflows can improve them. He ensures they're getting the products they need and they're efficient and successful. When he's not working on proof of concept ideas or talking to customers, you can find Cal enjoying Boston, most often running along the Charles or visiting our local breweries. I will leave you in their capable hands, and we're going to start off with Blaine today. Enjoy the webinar.
Hello, first of all, I want to thank everyone for joining us today, as we're hoping to add some value to your current and future projects and planning. And I want to tell you that my years in records management has really pointed out the critical role that PDFs play in the importance of document security, which really is what led me to iText. And before we dive into the agenda, I wanted to introduce you to iText. So we're an open source software company. We've been on the market for over 20 years, one of the largest producers of PDFs globally. And unlike a lot of the off-the-shelf solutions, we were built in the back end by developers for the developers. I know marketing uses that a lot, but we honestly were. And what started off as PDF creation has continued to evolve into merging HTML, rendering, redaction, digital signatures, PDF optimization for a few. And our abilities continue to progress. So although we're having this over the top 4 ways today, we can continue to support you in many different areas. And over the 20 years, we have also built an enormous community on GitHub, Stack Overflow, where we continue to collaborate and innovate. And we really help secure repeatable processes for our clients. We have thousands of customers, and they span from the smallest startups to the largest healthcare and financial organizations, and equally for this call, from the smallest counties, state departments, and even the largest federal entities. In my career, I've had the great opportunity to interact with and understand the different initiatives, needs, approaches with SLED and Fed. You know, I attend all the events. I've been to AIM, I've been to AMBA. You know, whether it's the mandate a few years back to reassure an electronic records management system for the federal government, very involved in that, or the want and futuristic want for a single login site for each one of the state departments, or all the ongoing modernization efforts that we continue to see. You know, the common theme is security and digital government, which is in alignment with the top 2 CIO initiatives for 2021. We've spoken with counties, and over the years I've spoken with many different entities, but we've spoken with counties that still have a mandate to physically mail documents at least twice, even when they're getting returned mail. The cost is roughly 75 cents per mailing, which sounds cheap until you do the math. And truly the solution is a digital process. Motor vehicles have been working endlessly to create a better citizen experience, like putting televisions in the waiting area, which I've noticed. Some looking at using booths in the future that could identify someone with retina recognition. They continue talks around creating more secure IDs and even mobile applications to be your ID in the future, and the list goes on and on. You know, the common theme is how do we find more efficient ways to communicate and interact digitally while reassuring in identity and reducing the time spent physically in the DMV or the RMV. Health and Human Services over the last several years have been involved in a multi-step plan to modernize. A lot of them are using agile framework. I've been on site to see some of the great work being done. It's very interesting. I love it. It's around data management, document management, data quality, and it just continues in each one of the realms. And honestly, all of SLED and Fed have been working to modernize their legacy infrastructure to be future-proof. And now we're at the point for a need to secure a repeatable process that can reassure that you're, number 1, meeting regulatory standards. Number 2, you're creating a safe experience for citizens to do business. Cal? Okay, so today's agenda. We're going to go over the importance of securing your digital documents. We're going to do it in a couple of different ways. We're going to review the following with you. Cal's going to take you through encryption, password, certificates, redaction, which is critical, especially in the government, digital signatures, And then ultimately a hot topic of PDF portfolios and how to maneuver through those. And lastly, we're going to show you how to implement these options using iText. As I said earlier, we have many different methods for these things. We equally have many different capabilities. So outside of the spectrum here, please feel free to reach out to us, have a conversation. More than willing, we're working with several of the state agencies right now and federal agencies. So excited to have conversation with you. And lastly, we're going to jump into a Q&A and answer any of the questions that you might have. And I'm going to send it over to Cal. Thank you.
Awesome. Thank you, Blaine, for the introduction and for that overview of iText. And thank you, Elaine, earlier for the introduction to the webinar. And also a big thank you before I start to everyone who has chosen to tune in today, whether you are here live or if you're watching us maybe months or even years on the line on our YouTube channel. Thank you very much for tuning in today. So without further ado, let's get started with the top 4 ways to secure your PDF documents with iText. To start, we're going to talk about password encryption. And your first question might be, what is password encryption? Well, I'm sure everyone watching this webinar at some point today has logged into some kind of application, whether it's Microsoft Outlook for your emails, maybe you're on Instagram, or maybe a more vogue social media like TikTok. Regardless, you usually need a username and password in order to use that application. Well, password protected PDFs are really no different. A password protected PDF, when you open it, requires a password in order to access its contents. And let's just say that I am not a person who has a correct password for a PDF document, but I am someone who has knowledge of the PDF specification. With iText's password encryption, there's no way that any kind of hackers could access any of that encrypted information in the back end. And the reason that is because iText encrypts our password protected documents with the latest 256-bit AES level encryption, which is the latest level of encryption supported by the latest PDF standard. And here is a general kind of overview of what a password protection workflow might look like with iText. So we're going to start out on this arrow over here, and we'll start out with number 1. So starting up this whole workflow, our clients, customers, anyone utilizing iText is going to configure their security parameters. So first, for password protection, they're going to want to set passwords, of course, both a user and an owner password, which I'll mention in a little bit. Also, for that encrypted, protected document, they're going to want to set certain permissions on it. And behind the password protection, they're going to need to decide a certain encryption level or strength. And in this case, and most of our clients will choose to utilize the 256-bit level AES encryption because that's the most up-to-date standard, again, supported by the PDF standard. Next up, after all of our security permissions and configurations are decided, our users are going to perform any kind of document operations that they're looking to do. And of course, with iText Core or any of our add-on products, that opportunities are really endless. Whether you want to split PDFs, merge them, add bookmarks, redact content, which I'll talk about later on, add digital signatures, make PDF portfolios with attached files, add more content, remove content, really anything under the sun with iText is possible in the document space. After all those operations occur, our clients then close the document, either writing it out as an output stream, so maybe off to a different location within the same app, or to a certain file location. After this whole process is done, we're going to be left with a password protected document. And it might be just a simple document residing on our server or on our laptop. And this password protected document is going to have 2 passwords, as I mentioned earlier. It's going to have a user password, which is going to be the basic password that we just need to open the document and to decrypt its contents, as well as the owner password, or sometimes referred to as the master password. And that's a password with some special permissions, which I'll talk about in the next slide. More specifically, utilizing the password, the owner password allows a user to edit permissions of that document after it's been created. So someone with the owner password might choose to go in and allow a user to copy and paste text from that document. They might disallow the addition of annotations or comments to that document. that might allow form filling, printing, and any of those permissions are fully kind of configurable with iText. And as iText is a full SDK solution offered in both Java and .NET at our core, we've made sure that all of these different security configurations are incredibly easy to implement within our code. And as Blaine mentioned earlier, we want to make sure that with our code, all of our processes are incredibly scalable and repeatable through different workflows or use cases. So in this case, in order to implement these certain permissions in our configurations for password encryption, we have these very simple flag variables. Of course, each one maps to a different kind of permission that I talked about earlier. So allowing users to copy and paste content from the document, allowing the modification of content in a document, the modification of annotations, and on and on and on as simple byte array values. Now, this was a brief high-level overview of password encryption with iText, but let's hop into an IDE and look at how iText actually implements this in code. So I'm just going to pull up my IDE here. In this case, I'm utilizing IntelliJ, and therefore I'm using Java. And here we have a very brief example where I'm generating a password protected document. So to start on lines 14 and 15, I'm going to define a owner password, as mentioned before, that gives us the ability to modify permissions in the document, as well as a user password, which again allows us just to open and to decrypt the contents of that document. Then I'm going to load in my iText commercial license file, which if you're utilizing iText in a commercial sense, whether in a production or non-production environment, you're going to need to use and load in a license file before any kind of iText APIs are called in order to remain in compliance. Then I'll define a PDF writer, which is going to be our output PDF document. It'll be called SSN, because as we'll talk about later on, I'm storing a social security number in this document. And we'll define some writer properties. And on these writer properties, we'll define our user password, our owner password. We can set certain permissions for a password encrypted document to start. So in this case, I'm going to set a permission which allows us to print, or a user when they receive the document to print. And then finally, we have our encryption level. And in this case, I'm going to choose to encrypt the document with the latest 256-bit AES level encryption, as mentioned before. After all of these configurations have been set up, we're going to transition into the next part of our iText workflow with password encrypted documents, if you remember from that previous graph, which is adding content or performing operations. So in this case, we define a PDF document, which really is kind of the meat and potatoes of any kind of iText API operation. And we're going to add some text to our document. So here I add a paragraph. It says, this is my social security number, 123456789. And I apologize if this is your social security number. I chose this as I don't believe this is anyone's. So let's just say that this is some sensitive information. We really would hope that, well, for one, our password protection works correctly. So let's briefly verify that. So I'll open up our ssn.pdf document that we just outputted. And you could use any kind of Adobe, or not Adobe, but PDF viewer. In this case, I'm using Adobe Acrobat Pro. So let's open this up. I'm going to type in our password. Again, it was just owner. And we can see that I have access to all of the different contents of the file that I created. So I can see this is my social security number, this is the actual contents, and I have this extra paragraph that I added as well. If I go into the security permission details within Adobe Acrobat Pro, I can see that, for one, I can verify that our document has been secured with password security. And if I go into the details, we can verify that it's been secured with 256-bit level AES encryption. And just to briefly show you guys what that looks like in the back end, this is that same document opened up in Atom, a simple text editor. So here we can see the back end hierarchical content of the PDF document in a text format. If this was not encrypted, we would expect to be able to search for our SSN or any kind of words in our previous document. But as you can see, as I'm typing in this SSN, I can't find it anywhere in the document. And any kind of sensitive contents throughout our PDF document, any of the sensitive information is now clearly encrypted. It's a bunch of ASCII 16-bit characters that aren't necessarily legible to anyone, whether I'm a hacker or if I'm a common person. So with that, that was a brief level, or I guess, overview of jumping into password encryption in an IDE setting. Let's hop back into the presentation and move on to our next way that we can secure documents with iText, and that's through redaction. And redaction with iText is done through our add-on product called PDF Sweep. And just to remind you, redaction is the process of not just obscuring content on a PDF document, but also to removing the actual content from the back-end hierarchical structure of that document. And what that means is that we're not just covering up any kind of words that we want to redact, but we're also going into the back-end to ensure that hackers or people who have knowledge of the PDF specification can't go into the back-end to retrieve that information after we've removed it. With iText, we have two kind of main, methodologies for redaction. The first one is location-based or block-based redaction. So here we have an input document. Let's just say that we have this title and we have this context section. In either section, we don't really have sensitive information that we need to get rid of. However, we have this top secret section and we want to redact all of the content in this entire section. It would be incredibly tenuous to go line by line and to redact character by character. So we're going to apply a very simple block redaction to this section of the document. As you can see here, we do so. We apply a black redaction rectangle. And again, not only is this top secret section obscured, but it's also completely removed from the back-end content of the PDF document. We can also make, of course, finer block redaction annotations. So in this case, we define a block to just remove the word confidential, as well as our customer's PIN number, which in this case was 1234. But block annotations can be a tenuous process because if you need to redefine a certain rectangular area on your PDF for every single annotation, it could be a kind of slow process. So let's just say that I have a document and I want to redact the word world throughout it. In this case, I'll apply our second methodology for redaction, which is through regular expressions or through patterns. So in this case, we have the simple statement, hello world, and you can imagine that this is our input PDF document on the left-hand side here. What I want to do is to remove and redact the word world, but not to remove the exclamation point or the word hello or the space between the two words. With iText, this is made incredibly easy, and I'll show you later on through a code sample, but we can define a pattern that just has the word world, and this redaction occurs correctly, as you can see here visually. And not only is the word world removed visually, but I want to show off that in the back-end structure of the PDF document, the reference to the word world is now entirely removed. So on the left-hand side, we have the hierarchical back-end content of our input document, which just said the words hello world. As we can see, that content is still here, and we can access that information. After applying our redaction with iText and PDF Sweep, we now have this content stream for the back end of the PDF document. We have the same kind of text element right here. We have hello and then -2611 exclamation point. And what this -2611 is a reference to our block shape that we have replaced the word world with. So no longer can we access the word world. It's entirely removed from the back end of our PDF document, so we can consider that information secured. So moving on, we're going to talk about certificate encryption. And certificate encryption at a very high level is a means of encryption where you encrypt a document with the sole purpose of one specific recipient being able to decrypt and access the contents of that document. And the way that we do this in order to ensure that a certain recipient is the only one to decrypt the document is through keys and hashing, which I'll talk about on the next slide. So certificate encryption occurs with public and private keys, and the way that they're linked together is through mathematical magic or through hash functions. Public and private keys can be generated by any kind of service, whether you're using Oracle or any other kind of IT provider that your company already implements. And just to go over the two different kind of keys, the public key is a string of numbers, digits, characters that are fully accessible to the outside world. So I might have a public key that my boss or anyone else on my team would be able to access very easily to send me documents. However, I also have a private key, and a private key is completely private, as the name suggests. So again, it's another 16-bit string with characters, both ASCII, numbers, numeric, string, anything like that. And this private key is specific just to me. So it resides just on my desktop, and it's used to affirm and assure my identity in these kind of transactions. In this case, this public and private key interaction will be asymmetric, and let's talk about what that might mean on the next slide with a more real-world example. Let's just say that I want to send my friend Bob a message, and I want to send him a PDF document that says, "Hello, Bob," in all caps, because I'm very enthusiastic. In order to encrypt this document with certificate encryption, I'm going to utilize Bob's public key, which again, I have access to because it's public information. And the output of that encryption is going to be a 16-bit fully encrypted contents PDF document, which is represented here by this middle circle. As you can see, it's a bunch of kind of jumbled characters and numbers, which wouldn't be legible. We couldn't get "Hello, Bob" from that with the naked eye. Then Bob is going to receive this document. He might open it up and say, "Hey, you know, this is a little bit fishy. I don't know why Cal sent me this file full of characters, numbers, and a bunch of mumbo jumbo." And then you might remember, oh, this is probably a certificate encrypted PDF document. I'll utilize my private key and iText's simple APIs in order to decrypt the content of this PDF documents and then read it on my side. And then let's say that Bob took a look at this message and he wants to send back to me, "Hello, Cal." This whole process could just be flipped right over, and he could use his public key to encrypt the message, and I could use my private key to decrypt it yet again. So that was a high-level overview of how that kind of process occurs with certificate encryption, but let's take a look at iText's APIs and just see what this looks like in code. So here we have a code sample for encrypting a document with certificate level encryption. First, I'm going to set up my permissions. And again, this is going to be based on an integer, and all of these different permissions are simple flag values, so very easy to use. I'm going to use the getPublicCertificate method to grab the public certificate of the recipient of this document. Then, as mentioned before, I'm going to output or utilize a PDF writer to define an output location for a PDF document. And on this PDF writer, I'm going to define PDF writer properties and set up this whole encryption methodology in one line of code. So I'll utilize this public certificate that I grabbed, as well as the permissions that I set up. And effectively, that's all I need to do with my side of the token in sending out this encrypted document. As you can see, for such a complex process, it's just a few lines of code, which just adds more fuel to the fire of the fact that iText offers scalable, repeatable processes that are incredibly easy to implement. And then here's a code sample for if I were Bob in that previous example, and I wanted to decrypt and read an encrypted document secured with certificate level encryption. In this case, instead of defining a PDF writer, I'm going to define a PDF reader, which does the exact opposite of a PDF writer. It's going to take in the contents of a PDF document. And in my reader properties now, I'm going to provide my public key as well as my private key, as well as a few optional parameters. And again, just as easy as that, I'm able to decrypt the document and access all of its contents, which I do in the following lines to programmatically read all of the page content from that PDF document. So this process, you could imagine for companies or organizations or agencies that deal with many encrypted documents, this process is incredibly easy for unlocking and accessing that information and making it more actionable. And that was a brief overview of certificate level encryption. Let's hop into our last kind of pillar of securing your documents with iText, and that's digital signatures. And I'm sure a lot of you have used digital signatures at some point in your life, whether to sign a contract or any other kind of agreement, but let's go over what they are very briefly. Digital signatures are a means of agreeing to contracts or documents in the digital space. In the back end, cryptographic hash functions occur in order to ensure that the signer is exactly who they say they are and that the contents of the document are not being modified after the document is signed. And the main goal of digital signatures is threefold. It's to ensure integrity of a PDF document, so ensuring that a PDF document is not being altered after you sign it, which of course, if you sign a deed for a home for $100,000 and the homing agency was to change that to $200,000, of course, you would not be very happy. We also want to ensure authenticity. So that's the assurance that the signer of the document is exactly who they say they are. So if you are giving out a contract to a client or citizen, you really hope that whoever's signing that document is actually the true and correct recipient of that document. And finally is non-repudiation, which is that with digital signatures, we want to ensure that whoever signs the document can't deny that they are who they say they are after they sign it. And within iText, we offer a full suite of functionality for digital signatures. In fact, iText partners with some of the largest digital signature providers in the world, some of which you've probably utilized in the past. And powering iText in the back end and in a lot of these different applications and different services is very powerful hashing algorithms. And what are hashing algorithms? Well, hashing algorithms are cryptographic hash functions that basically turn some amount of data into a fixed size bit string. So that's going to be a string of characters and alphanumeric values in a 16-bit representation. And what's being used to hash content are the following. It's the MD5 algorithm, which is since deprecated, as well as SHA 1, 2, and 3, and RIPE-MD, which iText all has the support for. And just from a technical standpoint, how does a digital signature ensure that the contents of a PDF document are not being modified after that document is signed? Well, there's going to be a certain hash function, and based on the contents of a PDF document, that hash function is going to return a certain 16-bit string, as mentioned before. And if you were to run the same document through a hash function twice, the hash function is going to return the exact same values. So that's how that check occurs. So if I were to sign a document, I would sign it and then I'd send it up to a server. That server would then have the hash function for that document calculated and stored. If at any point that document was modified and the hash function was rerun, we would very easily be able to check between the signed hash function value as well as the modified one to see that some modifications have been made. And luckily, Adobe and other PDF viewer providers make this process very easily through full kind of visual means. But with iText, the actual processes of defining and creating digital signatures as well as signing them is incredibly easy. As mentioned before, these are scalable and repeatable processes that are incredibly agile and will scale up to your total document workflow. So here is a very brief code sample for defining a simple PDF signer class. In this case, it's just 3 lines of code. We're going to read in the contents of our PDF document. We'll define our PDF signer class, and this will enable us to sign a PDF document. Let's just say that we wanted to define a digital signature that'd be stamped onto a PDF document. Well, we have another very simply defined script here, which again is really just 2 lines of code that we've extrapolated out to be a total of 6. But in this case, we can define a PDF signature appearance, and this will define exactly how our digital signature is going to be appearing on our client's or citizen's PDF document. We can set very simple and easy to use parameters like the location of that document on the location of the signature on the document, as well as very specific parameters about its coloring and its total appearance. We can also set its name very easily, as you can see here. And finally, for signing a PDF document, the process is just 2 lines of code with iText. First, we define a external signature class, and we're going to use our different digest algorithms as well as our encryption measures and key stores all in this one process, bringing them all together in order to sign an existing PDF signature on a document. As you can see here, the actual meat and potatoes of this operation for signing a PDF document occurs in just one line of code. We use the signed attached method to take in our certain digest for that signing operation, as well as the kind of standard and certificate standard that we're using in this process, as well as our key store and chain and a number of other parameters. So those were brief overviews of the main ways that iText customers, clients, citizens will be securing PDF documents. In the next section, we're going to be talking about PDF portfolios, which a lot of our government clients have been finding a lot of value in recent years. To start, what is a PDF portfolio? It's not necessarily a term that you hear every single day, but basically a PDF portfolio is when a PDF acts as a container for other attached files. So the way that I like to think about PDF portfolios is kind of like a cup. So in this case, the PDF is the actual structure of the cup. It's the clay in the sense if it was a mug. And inside of this cup, we have all of our different attached documents kind of making up the contents. You might ask yourself, well, what kind of files can be attached to a PDF document? And the answer there is just about any, whether it's a Microsoft Office document, a text file, an XML file, a movie, it could be a video, TIFF, image, a different PDF file. It really could be anything, and the opportunities are endless. And in this slide, we're just going to go over it. I'm just going to show you guys. This is what a PDF portfolio looks like in practice. So again, this is a screenshot from Adobe Acrobat Pro. And by opening up our attached files tab, we can very easily see any kind of attached files on our PDF document. In this case, this Hello World PDF document is acting as a container. It can still have content or attributes added to it itself, but it acts as a container for these other Excel documents, JPEG, XML, Microsoft Word documents, all of which we can open from this PDF document. And why am I talking about PDF portfolios during a security webinar? Well, it's because, again, a lot of our government agencies that we work with have found a lot of value in combining PDF portfolios and different encryption measures in order to serve as a secure container for their clients and citizens' documents. And in order to contextualize that more, I'm going to hop into two brief use cases. In this case, the organization names are kept general in order to preserve client data, but these are based on real kind of client use cases. So the first one is, let's just say that we have a state office for children, youth, and family services, and they're looking to create a completely secure document workflow for families looking to adopt children. In this case, their need is to aggregate all of the different adoption forms necessary for the process, whether it's text files, Microsoft Word documents, Excel, anything like that. And they want to aggregate and containerize all of these files in a fully secure and encrypted manner, such that only users with a password, so the adopter families and the agency, would be able to access the contents of that document. So with iText, this workflow is displayed here. So first up, we start out with our client data. These are the different kind of adoption forms for this use case. We're going to use iText in order to configure the password protection of a PDF document. And we will also use iText APIs to attach all of these different files to our PDF document to effectively turn it into a PDF portfolio. After all these operations occur, we're left with a fully secured password encrypted PDF portfolio, which you can see here is, again, we're using this analogy to a cup where the PDF document is a container, and in this case, it is locked and secured with password protection up to 256-bit level AES encryption. Next up, let's just say that we have a federal tax audit organization, and their objective every single year is to collect tax documents from all of the citizens in their country. They maintain a web application, and every year, citizens can opt to upload their tax forms very easily into this web application. The Federal Tax Audit Organization wants to ensure that any kind of sensitive client information that's being uploaded into their web app is being fully redacted and secured. So whether it's a social security number, date of birth, other personal identification numbers that might be sensitive information, they want to make sure that all of it is redacted so that they have full security for their citizens. Then they're going to aggregate all of the customer's tax files for that certain year into one PDF portfolio that's going to have all that information redacted. So here's how that use case might look with iText. So they'll start out with their input files. These, in this case, will be all of the different tax forms that a citizen might upload to their web application. They'll utilize our add-on tool for redaction, as mentioned earlier, PDF Sweep, in order to, on batch or on demand, redact any kind of sensitive information from those PDF documents. Then they'll be left with a series of output files with all of that sensitive information redacted correctly. And then finally, we'll use iText again to aggregate all of these redacted files and to add them into a PDF portfolio, which again will effectively containerize all that information, making for easy archiving on the side of the Federal Tax Audit Organization. So those were two brief use cases into the usage of PDF portfolios for and how they synergize with encryption measures. But let's hop into the IDE yet again to go over another example and to show off how PDF portfolios would look in code. So in this case, we'll start from the top and we'll go down line by line. I'll zoom in very closely as it seems that my text size is a bit small. That looks a bit better on the preview screen, so hopefully everyone can see that. We'll start out by loading in our license file. And to remind you, for any kind of commercial application, whether production or non-production, it's always required to load in a license file as the first step in the iText processes. We'll then define a PDF reader, and this PDF reader is going to open up our document that we defined earlier. I'm just going to open up that document just to remind you what that looks like. So here it is yet again. We have the content of this document. It says this is my SSN. It's 123456789. Our objective in this use case is going to be twofold. It's going to be to redact that sensitive information from that document using PDF Sweep. So we're going to get rid of that SSN entirely, and we're going to remove any kind of references to that SSN from the back end of that PDF document. And two, we want to add a bunch of different files in order to aggregate all of this information into a single containerized format. Again, utilizing PDF portfolios. In this case, I've chosen to attach an XML file, a Microsoft Word file, a JPEG file, and an Excel file. But first, let's go through this first line. We define a PDF reader, which again is going to be used to take in the contents of our PDF document. When opening up the PDF or this password protected PDF document, we're going to give a owner password so that we can modify any contents in that document and also determine any kind of security permissions of the subsequent output document. Next up, we're going to be using PDF Sweep in this case in order to define a regular expression based cleanup strategy. And what's great about PDF Sweep is that we have many different common regular expressions or patterns already defined and baked into our API. So in this case, we're going to use our US social security number pattern, which is already predefined. And we should expect that we don't need to have any extra configurations. In this case, that the 1234567 SSN is going to be automatically redacted. And we're going to set the redaction color in this case to be pink. We'll set up our PDF Sweep object, and we will call the cleanup method to automatically go through and apply those redactions, again, not just visually, but also to the back end of that PDF document. Next up, in order to satisfy the PDF portfolio part of this use case, we're going to use the add file attachment in order to attach files to that PDF document that we're outputting. And let's take a look at this add file attachment function. Like all of the iText processes talked about in this webinar so far, this is an incredibly agile, simple, and easy to use process, lending itself for scalability and repeatability over different use cases. In fact, the meat and potatoes of this operation occurs with the create embedded file spec function. This takes in any kind of necessary parameters like the actual file stream, the name of the file, the MIME type of the file, what we want to call that file, a description of that file in our output PDF document, as well as some other optional parameters. This kind of configurability of iText, in this case for our attached files, makes it an incredibly valuable solution. We can modify any kind of attributes programmatically so that someone in a post-processing sense doesn't have to go in Adobe Acrobat or any other PDF viewer and manually modify that content. We'll then use the add file attachment in order to successfully add all these different files to our PDF document. And then finally, let's run this function, and we will open up our PDF document in order to show off how this all works. All right, and here we go. Let's open up our output document. Here we go. We have this is my social security number, and then previously we had the social security number of 123456789 here, but that's been totally redacted. We can't select it at all. If I were to Control A and copy and paste any of this information, you'll see that none of this is actually accessible from us from a user standpoint. Let's also take a look into the attached files function within Adobe Acrobat, and we can see that all of our files have been attached correctly. And not only that, but all of these files are fully accessible from this containerized PDF document. So I'm going to open up this dog.jpg file. We can see, hopefully, a photo of a dog appear. Yep, as you can see here, we had the high definition photo of this dog attached to our PDF document. No problems at all. It was fully accessible from the PDF portfolio. So in this example, we've shown how we can utilize PDF portfolios and synergize them with different encryption and security strategies in order to create a secure, containerized document standard for different files or for sensitive client data. So for now, we are going to transition into the Q&A portion of this presentation. If you have any questions in the chat, please feel free to add them. If you have any kind of longer questions, please feel free to send them over to marketing@itextpdf.com. And I guess before I fully stop, I just want to say thank you to everyone who showed up today and who came in. Of course, we're incredibly thankful for all of our support among the government agencies. And I see Blaine is now rejoined me now, and there's Lane too. Hi, guys.
Thank you, Cal. So we had a couple questions come in.